And then you can say, oh, well, 8 plus 1 to the second power is 81, or 9 squared. So what's happening here? Well, the sum of these two digits, 8 and 1, if you add them up and raise them to a power, you can get that number. So 81 is one of those numbers. And you want to think, are there other numbers where this happens? Like 16, for example, does that work? Well, what's 1 plus 6? That's 7, right? 7 to any whole number power, right? Is there any whole number that can square this to get 16? The answer is no, so this one doesn't work. Well, what about a number like 25? Again, 2 plus 5, oops. Again, 2 plus 5 is 7, and 7, there's no whole number, oops, that I can multiply by, no whole power that I could raise 7 to get 25. So what numbers actually work here, and how do we find them? Well, one other such number that works is 4,913. In this case, if you take 4 and 1, 9 and 1 and 3, right, and you raise it to the third power, that's like having 17 to the third power. And if you test that, this means 17 times 17 times 17, you will get 4,913. So what's going on here? Well, to be honest, I'm not exactly sure, and I'm not sure how to discover these numbers. I came across this list, and I wanted to share it with you so you can play with this. The number 512 is one of those numbers that works. Another one's 5,832. Another one's 17,576. And we have much bigger numbers as well. And we can even group these as well, but I'll show you what I mean in a moment. 2,401, 234,256, and then we'll show, I think, one that's a little bit crazier here, because this keeps happening. There seems to be no end to the numbers that work or fit in this category. There seems to always be a number as you go up that you can make this work. Okay, so what are each of these? Well, the first one, 512, we're going to think of that as 5 plus 1 plus 2, and that's 8. And if you take 8 to the third power, you get 512. So this number has that cool relationship. And I grouped it with this number here because this is like 5 and 8 and 3 and 2, which is 18. And 18 to the third power gives you 5,832. And then these three, oh, and then the last one in this group, we have 17,576. If you take 1 plus 7 plus 5 plus 7 plus 6, what you get is 26. And that to the third power gives you 17,576. So in this group, this is why I grouped them, each of these uses the third power. In the next group, we can work up to the fourth power. So this is like 2 plus 4 plus 0 plus 1, which is 7. And 7 to the fourth power equals 2,401. And the same thing at this number as well. We can add 2 and 3 and 4 and 2 and 4 and 5 and 6. Oh, excuse me. And that equals 22. And 22 to the fourth power gives you this big number right here. So in these two, we grouped them because they had a power of 4. And I don't think there's any power, any whole number power doesn't have a number that fits in this group. You can find numbers for powers of 5 and 6 all the way up to this last one here, which is really broken down to the power of 8. If you add up all of these digits, what do you get? All of these digits. Add them all up, and what you should get is 63. And 63 to the 8th power does equal this number. So I just think it's fascinating, you know, what's going on here? How come these numbers work? How can we find them? What can we do? And there's some even much larger numbers that go into like 20th power as well. So it's fun to think about, is there a limit to this? Could we keep going for any exponent? And how do we find these numbers? So I hope you enjoy those two questions because I've been wrestling with them for a while. Thanks.